Hello friends, welcome to my YouTube channel To The Point. Our today's topic is proportions. Two related quantities stated side by side is called a ratio. For example, if a recipe calls for 3 eggs and 4 cups of flour, then the ratio of eggs to flour is 3 to 4. Eggs 3 and cups of flour 4, 3 by 4, and in ratio we can write 3 semicolon colon 4. This fraction is also amount of per unit of the given ratio, in this case 3 over 4 eggs per cup of flour. Two ratios that are equal are said to be in proportion. Two ratios that are equal are said to be in proportion. Thus 3 to 4 is proportion to 6 to 8, since 3 by 4 and 6 by 8 is equal. Proportion equations are the simplest type of fractional equations. To solve proportional equations, cross multiply and change the proportions into regular equations. Cross multiplication rule: if A over B is equal to C over D, then by cross multiplication AD is equal to BC. Example, solve for x. 3 over x is equal to 5 by 2. We cross multiply this. 5 into x gives 5x, and 3 into 6 gives 3. 6 3 into 2 gives 6. That is 6 equals 5x. Also written as x equals 6 over 5. Question number 2. B 2 over 3 equals x plus 2 over x minus 5. We will cross multiply it. 2 into x minus 5 equals 3 into x plus 2. Multiply the 2 into by the x and minus 5. 2x minus 10. Similarly 3x plus 6. We isolate the x terms on one side and the constants on the other side. This gives the value of x minus 16. When setting up a proportional equation for word problem, the two quantities for the same type of measurement must occupy the same proportion in the fractions. Both must be in numerator or both must be in denominator. For example, a recipe calls for 3 eggs and 4 cups of flour. How many eggs are needed if we have 10 cups of flour? Let x be the number of eggs needed. Write the two types of measurements, the number of eggs and the number of cups of flour, in common as shown. Number of eggs, cup of flour. Number of eggs will be x and cups of flour 10. X over 4, 3 by 4. Set them equal, we get this equation. Here we can easily find out the value of x by cross multiplication. 4x equals 30, x equals 30 over 4, that is 7.5. We need 7.5 eggs. Example C. On a map, 4 inches corresponds to 21 miles in real distance. What is the real distance between 2 points if they are 14 inches apart on the map? Let x be the number of real distance in miles and write the two types of measurements as miles and inches. Miles denotes by x, inches 14, x by over 14. Set them equal, x over 14 and 21 over 4. This will easily solve the value of x, that is 73.5. So 4 inches correspond to 73.5 miles. Geometric proportion gives us the sense of similarity, that is, objects that are of the same shape but different size. Given the following cats, which cat on the right is of the same shape as the one on the left? Cat A, cat B. We can easily see that cat A is same as the cat on the left side. The answer, of course, is A. This sense of similarity is due to the fact that all corresponding linear measurements are in proportion. For example, given the following similar cats, let's identify some corresponding points. Suppose the following measurements are known: 3, 6, xz, 10, 12. Definition: two geometric objects are similar if all corresponding linear measurements are in proportion. Hence, if x, y, z are the measurements from the original cat are shown, and x, y, z are the corresponding measurements in the similar copy, then it must be that capital X over x equals capital Y over y equals capital Z over z, or that capital X over capital Y equals small x over y, etc. This mathematical formulation of similarity is the basis for biometric security software such as facial recognition system. The reason that linear proportionality gives the sense of similarity is due to the visual geometry, that is, visual images of an object at different distance form a cone. This is example of cone. One can easily demonstrate that in such projection, similar images of two different sizes must preserve the two ratios corresponding distance measurements as in above definition of similarity. In the definition of similarity, the measurements in proportion must be linear. It's not true that the ratio of area is proportional to linear ratio of two similar objects. Because the ratio of linear measurement is 1:2, we may conclude that the ratio of the area measurement is 1:2 square or 1:4. So it would take 4 times as much paint to paint that large one. Given two similar objects with linear ratio 1:r, that their area ratio is 1r square. This is also true for surface areas. Two similar 3D solids of 1:r linear ratio have 1:r square as their surface area. The volume of an object is the measurement of the three-dimensional space that object occupies. Because the ratio of the linear measurement is 1:2, we may conclude that the ratio of volume measurements is 1:2 cube or 1:8. So the weight of large one is 8 times as much as the small one. Given two similar objects with linear ratio 1:r, then the volume ratio is 1:r cube. The golden ratio, an important ratio in arts and science, is the golden ratio. Cut a line segment of length 1 into 2, a long one L and short one S, such as the ratio of 1 to L is same as L to S. The diagram shows that the ratio 1 over L is the golden ratio. Since S equals 1 minus L, we have 1 over L equals L over 1 minus L. Cos multiply gives 1 minus L into L square equals L square. We'll see later that the answer of L is about 0.618. So friends, thanks for watching. Let's meet in the next video. Allah Hafiz.